are going to update you on how we're going to build the next version of our Thinkwise platform and of the new version of the software factory. And as you know, we eat our own dog food in this company. And so we are delighted that one of the software engineers actually put his hand up to present this to you. We're going to look into how we're going to stimulate and promote innovation in the product, but also how we're going to safeguard and maintain a high level of quality and usability. And without further ado, I would love to ask Mark to join me on stage. We're delighted you put up your hand, so give him a big warm welcome. The man who normally lives behind the screen.
Thank you. Thank you, Connie. Powering innovation. The Thinkwise Platform represents the cutting edge of mission-critical application development. In this session, I'll take you on the journey of how we develop our own software factory, our development studio. I'll take you through our iterations, but also, most importantly, how we ensure the quality of the platform. How does the platform look like? Twice. The Thinkwise Platform consists out of multiple components. And I'd like to start with the software factory. The software factory is the place where you build the blueprint of your application. The model, as we call it in the software factory. The software factory model consists out of tables, screens, columns, process flows. But also, you can create your own code templates. You can add to the functionality of the Thinkwise platform by utilizing SQL code. We also have testing functionality, like unit testing and smoke tests that we introduced this year. And with these tests, you can ensure that the application you build is safe, secure, and works the way it should be. The model of the software factory, the model that you create, you can synchronize into the Intelligent Application Manager. In there, it provides authorization, analysis, and user preferences over that model. And it's typically run in like test or acceptance or production environments. For this talk, it's a bit irrelevant, but I did want to mention it here, because it is a vital part of our platform. Interacting with the software factory is Indicium, which is our application tier, which is the application tier that connects to the database, the model, and your application, as well as other services far away from here. And then, of course, we have to show the application. Our graphical user interface universal is our 7th generation. Already seven generations of user interfaces. And this one is super special, as it can run on any device that has access to the internet. On your laptop, on your computer, on your mobile phone, and maybe in the future, even your toaster. You never know. Let's dive into the software factory, my favorite. The software factory is an integrated development environment in which you can create your models, your applications. And the fun part about the software factory is that it is built with the software factory. The model of the software factory is inside the software factory. This way, we make the platform utilizing itself. The size of the software factory is about 25,000 function points, which is kind of the same as a large ERP system, also built with the Thinkwise platform. And the nice part about the software factory is that it's largely dynamically generated. We have procedures in place that generate a large majority of what we offer you. For instance, the merging capabilities of the platform, in which you can have a copy of the model and merge it into another copy of the model. A large majority of this is dynamically generated, because all the 250 different entities within the model have to be compared to each other. This can all be dynamically done. And that's what we do. So if there is something that we need to change, we want to change the color of an icon on the right, we can do that in one place. And it will update all of the 250 different screens behind it. And that makes working on the software factory so fun. I only need to change one thing, and the whole process benefits from that. There are parts of the software factory that are up to 90% generated, such as detail references, detail screens, like the compare tab page. But also the functions that we use, or the procedures we use, to find the differences between these copies. Also generated. We of course also have the history functionality, in which you can see all the changes that are done to your data, to your model. Over time, when you create your model, things change, things get added, things get removed. And all of that is nowadays stored in history. And you can see that on about every single entity within the model. For instance, columns, but also for your tasks, but also for your functionality. And what you see is that they look exactly the same. And that is because they are dynamically generated as well. That means if we wanted to change the screen, we only have to change it in one place. And everything will be updated. Well, how do we develop? We utilize Scrum, and that is not only for our team, but also for our whole product innovation department. All of our teams work in 4-week cycles, in which we develop the next version of the respectable component. We utilize for that Azure DevOps, and that is our project management tool. We use it for our product backlog, for sprint backlog, for our code repositories, and much, much more. Azure DevOps helps us obtain what we want. There are multiple tools for that. You can also use Jira and all kinds of other tools. The Software Factory development team creates a branch per user story. And a user story is a piece of functionality we want to improve, we want to add to the platform. And we create a copy of the Software Factory, a branch. And when we do that, we develop the functionality, we test it, we accept it, and only when we accept it, it gets merged into the next version of the Software Factory. We not only have one reviewer, we actually have 2 reviewers. One reviewer is a teammate, and another one is a domain expert. And the domain expert being a person that knows everything about the functionality and how it should be implemented. With 6 eyes looking at it, we can make sure that what comes into the next version is correct, is exactly what we wanted. We also have a definition of done in place, which is a checklist of items, and only when all of these items are approved, the user story is finished. We care a lot about the stability and the reliability of the Software Factory, so you don't have to. At the end of the sprint, we have a shippable product, as we call that. A shippable product that we could give to anyone, and they could install it on their own environments. With the shippable product we can upgrade our own environment. Our current version, Software Factory, will go to the next version, as well as our team environments. Indicium, Universal, and all of our other components benefit from this. They always run on the latest version we release. Well, how does a normal iteration look like? And before we had quite a large, that's why it's also so big, quite a large development cycle. We started to develop 4 months, 5 months, then we started testing it for about a month and accepting it. And only then we created a major release, 23.2 for example. But that is very, very slow. 5 to 6 months is not what we want. We want to release quicker. We want to bring you the functionality quicker than ever before. So what we did internally, we optimized our processes so we could release every single iteration. Every 4 weeks, we are able to release a minor version. Version 1, for example, without losing control. We still have the same cycle as normal. We develop, we test it, we accept it again, because all the user stories have already gone through this cycle. But then again, at the end, we want to make sure that the version we deliver is the version we want to deliver. It is up par. So then the new iteration comes, and we have a new version. And then another iteration comes, another new version. And all of that will go one after another, until we decide, this is it, we want to release it to the world. And that's what we call a major release. The benefit of this is that we can release it to ourselves, that we can test it ourselves, and optimize it in the iteration to come. So when we have the major release, it already went through 4 cycles, or 3 or 4, or 2 cycles to improve it, to make it better. And for example, the merging functionality, we already wanted to make that a lot better because it was quite technical. So we had in 1 iteration, we added new screens to make it more easy to understand what merging actually does. What data is inserted or updated? What will be reverted based on the conflicts you have and how you resolve them? And then my colleague came and he said, like, that's nice, but it could be better. So we added explanations to it. So now when you want to resolve a conflict, you know what is going to happen. It will explain to you that the conflict you have, that the column will be removed and the table will stay there. Or that the code difference you have, which code template it will actually choose. And that's really awesome. And all is going to be in the next version. I'm already delighted. Well, how do we release an iteration to ourselves? And that's what we call a development environment upgrade. Our development environment, just like yours, is a software factory and an intelligent application manager. And nowadays it's completely automated. Before it was manual, which was horrible. It was like a 800-line script, and we had to do it by hand, one by one, to make sure that the data was correct. We created deployment packages, and eventually we had to go out of the script because we had to open all of the upgrade scripts one by one, and we had to upgrade our intelligent application manager and the software in the area too. Yeah, indeed. That was problematic. You might recognize this. You have a software factory in which you build your application that will upgrade your end product. But in our case, the end product is our software factory, because we built the software factory in the software factory. So when you put the software factory in the middle, it upgrades itself. The software factory is generating those upgrade scripts to itself. So how do we do that? We have 4 components in that. We of course have the software factory, in which we have a CI/CD application, continuous integration, continuous deployment, in which we can make sure that the data of our model is up par. We need to make sure that when we release this minor version, that the version name is correct, that all the paths that we have in the software factory are correct, many more other things. This application allows us to prepare the environment for the next version. We use the Indicium API to make sure that we can create those deployment packages. So we can create the scripts necessary to upgrade our software factory to the next version, as well as the intelligent application manager. And lastly, we put it all together using Azure DevOps pipelines. And a pipeline is essentially a series of actions after each other, done by the system autonomously. You press start, it does something, and it's finished. You don't need to look at it. Well, we're going to take a look at one of our pipelines. We have many of them. But one of our pipelines, the most interesting one in this case, is our development upgrade pipeline, in which we bring our application from the version it is to the next version in a single click of a button. It will back up our databases, just to be sure, and then it will prepare the environment. Like I said, make sure that the version names are correct. Because for us, if we have a version name incorrect, all the components don't know what they are looking at. We need to make sure that the version we release is supported by our components. If we suddenly would release version 3000, our Indicium team would be like, what is this? So we need to make sure that that's correct. Validation steps are included. So once we have everything correct, everything set up, we can upgrade our databases. And the fun part about this, we actually use our own platform. We use the Thinkwise Deployment Center, the one you also use. This is the code we use. We use the command line possibilities of it. We make sure that we're going to upgrade the Intelligent Application Manager. And it's very similar to how you would do it. The model can be your model, and the database is your database. Those are the only two differences, probably, between how we do it and how you would do it. So after all of this is done, our Intelligent Application Manager and Software Factory is to the newest version. We're now running in version 2. Next up is we want to, of course, start developing. We want to now start version number 3. So what we do, we generate our development branch. We synchronize it into the Intelligent Application Manager. And after this pipeline is finished, we're done. We can start our development immediately. In simply 1.5 hours, we brought ourselves from a previous version to the newest version. 1.5 hours. Before we needed like 2 days or 1 day after we got it a little bit better. But now 1.5 hours. It's crazy. If you ask me, at least. Well, how do these iterations work with each other? Of course, we have the software factory, but you also have other components, such as Indicium and Universal. Well, these iterations, they are subsequent of each other. They fit each other. So, once we develop functionality, and it's ready in the model, available, Indicium can start to support it. And thereafter, the Universal GUI can talk to Indicium and retrieve that information it needs. Usually when something big gets implemented, we start with an epic design, as we call that. Our architect, that's currently in Japan, will write something down and think it out. And in this case, let's use the change detection as the example. Change detection is a logic concept we introduced in 22.1, long time ago. 22.1, in which you can configure, you can make sure that the auto refresh functionality of the platform can be turned on or off. You can decide whether or not your data set should be refreshed. It's very powerful, but only powerful when all of the components support it, of course. The software factory implemented it first. We made sure that there are procedures, that there's a code group you can hang it in. You only need to write the body. We already made sure that the header and the footer are automatically generated. Once you have that body, the procedure is there. It's part of the model. Then you have Indicium. Indicium will call that procedure because Indicium is the one that calls the database and interacts with the application. So Indicium needs to support it in the next iteration because it has to be part of that model. The next iteration, the Universal GUI can start to integrate it because now it can communicate with Indicium because it has that knowledge. Universal will now refresh the data based on that 1 or 0 that they get from Indicium. Should I or should I not? Well, it goes to 3 iterations, but how do we ensure the quality then? Because the platform is built with the platform, we use a practice called eat your own dog food, in which means you use your own products or services to build those products or services. Next to that, we have, of course, automated testing. We need to make sure that what we release is the quality we want to release. Every night, we run all of our unit tests. We run a smoke test. We install the next version of the software factory. And we upgrade from a current version to that next version. Every single night. Just to make sure we can release it. And to be honest, pretty much every night, we should be able to release that product to you. We could make nightly builds. Sadly, not all functionality in that is then up par yet, because of course, functionality has to work together. Nevertheless, you always have manual testing. There are scenarios in which you have to manually go through your application. For instance, if we want to test the merging capabilities, we have to have 2 copies of the model, we need to make a lot of objects, and we need to merge them, and we need to make sure that the screens are correct, that the actions are correct. And that's something we currently don't have automated yet. But in the future, we could. When the software factory is on universal, we can create those tests, so-called end-to-end tests. More on that later. Like I said, the platform can, of course, test itself, but we also have Indicium, a universal GUI that tests the platform. Because they interact with it, and they need to make sure that what they get is correct and what they give is correct. When we implement new functionality in the software factory, we write tests. The platform has tests. The next iteration, Indicium will support that and write their own tests. The next iteration, Universal GUI will support that functionality and write their own test again. Layer upon layer, simply to ensure quality. Whilst the platform can, of course, test itself, the Indicium and Universal are not written inside the platform. They are written in their respective code languages. So we utilize third-party tools just to ensure the quality. We use Sonar Cloud for our code quality and our security. Indicium use XUnit to run the unit tests. Universal uses Jest as their testing framework. And lastly, they utilize Cypress for their end-to-end tests. To simply make sure that when you open the menu, until the last finishing touch of a button, that the whole process is correct. That the screens are the same too, visually. It can visually test if it is correct or not. So how does it look like? The software factory has about 700 unit tests that are run every single night. We run a smoke test every single night, just to make sure that when you open up a view, call a function, that it always works, that it returns the data you want. With 700 unit tests every single night, we already accumulated this year 250,000 unit test runs. Over 400 smoke tests. 3.2 million individual steps that have been tested automatically every single night. Indicium, 4,200 tests with 8,500 assertions, just to make sure that the data that gets in or the data that leaves is the correct data, the correct value, and that everything works properly. They run it about 4 times a day. 4 times, 4,200 tests. Universal, 3,500 unit tests every single night. But also every single build. Every time a developer is busy and creates a build of the Universal GUI, it runs all of these 3,500 tests. And only when all of these tests succeed, it gets added. Next to that, 400 unique end-to-end tests, just to guarantee the quality of the universal GUI. And lastly, a third party. We invite a third party to pen test our platform. We don't want your data on the street. We need to ensure that quality. We need to ensure that everything goes well. All of them combined is the quality of the Thinkwise platform. What I want to give you in this session, some key takeaways, is that no model is too large. The software factory is a very large model. Like I said, 25,000 function points, comparable to a very large ERP system. But no matter the size or the complexity, the amount of developers you have, you can guarantee the quality of that. You can automate your tests. Think to yourself, when would you run all of these test capabilities that the software, that the platform offers? All of your unit tests, your smoke tests. Think, would you want to install a version of your application every night, just to make sure that it can install? Find out those pesky little bugs that you otherwise would find in production. Don't want that. And lastly, deliver quality at speed with CI/CD. When you use CI/CD, you have a process that runs from start to finish in one way. Consistency, stability, automatic logging. So if anything goes wrong, you know what is the problem. And you won't find that out at the end of your release. But you know that immediately. You can deliver your application with a click of a button. We ensure the quality of the platform, and you only need to test what you develop with the platform. And with automation, any model built with the Thinkwise platform can be as stable and as reliable as the Thinkwise platform.